Neutkens. That's how you pronounce it, right?
Neutkens, but it's very
Neutkens.
hard to pronounce. Yeah,
For
it's like the
Americans.
O is it's like
Oi,
EU is O, and O
oi.
is very particular like sound that doesn't exist in
That's,
English.
yeah,
The
oi.
same as like O, so double like O. But that was easier to pronounce. And we also have E, which is like I, E, and then what those sound sort of similar, but like O is very specific. But like most of the time, English people will pronounce it as Neutkens,
Neutkens. Cool.
which is like Newt and then Kins or something, which
Nice.
also sounds very similar. And like I literally don't care, so
Yeah.
like whichever
Cool.
works.
Cool. All right. Well, yeah, let's get started, man. Today I'm excited to talk with Tim Neutkens. He is been on the Next.js core team, I guess lead maintainer and Vercel for about 6 years. So probably Next.js before that. How long you been working on Next?
Almost 7 years, I think. It's definitely been a long time. Yeah.
Nice. Cool, man. So we've had a few episodes on React Server components, and you and I had a chance to work together last year, and you were telling me recently, like you've been hearing some of those episodes, and thought it'd be fun to come on and chat about it because obviously your life has been like React Server components lately, and so I thought for this conversation, it'd be fun to basically just talk recap the last few episodes, make sure kind of what we're saying is how you think about how things work. Specifically the rendering stuff, the server side rendering versus the server component rendering, and because I know it's helped us just understand kind of the mental model, and then maybe we can
Yep.
talk about some of the caching stuff as it relates again to the mental model because I think uh, from some of your discussion on Twitter it seems like I always find it helpful to hear how the creator and maintainers of a project think about the mental model for a tool because it can be easy, especially for programmers, to just dig into specific APIs. But when you understand how it's intended to use, which parts you're supposed to be thinking about, as an app developer, and which parts should kind of be abstracted away, I feel like that helps a lot. So that's what I was kind of hoping to get out of this conversation.
Yeah, definitely. Sounds good.
Cool. So, yeah, let's just do a quick recap and make sure kind of some of the stuff we were saying in the last few episodes was correct. I think the big takeaway was for us and for some other folks was just understanding rendering server component tree versus rendering as it relates to actually getting something into the browser. And my kind of TLDR here is uh, when we talk about rendering server components, we're talking about this kind of higher level abstract concept of turning a tree, getting a tree as a result of rendering some code, basically. And there's this two-step pass of rendering that happens on the server. You render a server tree into a client tree, and then on the initial request, that client tree can come up as HTML, and so the browser can request it. Let's just set aside streaming versus like render to string from now. I think at a high level, right, the browser just gets the HTML representation of the client tree that came from the server tree. And browsers know how to paint HTML, so that's how it gets painted. And then on subsequent requests, the server renders the new requested server tree into a client tree, but instead of giving it as HTML, it gives it as a JSON format, which is the RSC payload, which the React app that's now running in the browser knows how to render, knows how to paint, and it has create elements, but it also has references to client components that are already loaded up in the browser. So those are like the two ways that server components end up getting painted to the screen. Is that more or less kind of accurate?
Yeah, that makes mostly sense. The like the way that we've been talking about this is not exactly like client tree per se, but it's what we call the RSC payload. So the React Server Components payload. That one is basically you render the server components. So you take the server components tree, You render that using like this React API for it. You basically give it like a like React components in a sense. Like we basically like wrap everything into a virtual server component, like another module that's like wrapping all like your code so that we can create a server component that basically renders all your like layouts and loading, and it creates suspense for that, adds in the templates, like that kind of thing. So that is rendered to this like intermediate representation. That's the RSC payload. So RSC payload, you can do two things with that. Like one is you can render it to HTML. So you basically call the normal like React DOM render to string. In our case, we use render to stream so that it can do streaming. But you can also call render to string on it. Like that's what we do to create like static HTML. Um, so in a sense, like you were saying, that's like the client component tree in a way, right? Like you're basically like creating a React tree that is like has all the like from the server components tree, it basically like rendered to like all the divs and all the p tags and all that from that like server component. But then if there is a client component you're rendering in the server component, that would be a reference in this like payload. And then like the render to HTML or render to string is used to basically like that knows how to use those references to then like require the right code on the server or on the client, to then like load the code up and start rendering that as well. So in the server component, like RC rendering pause, that's the first one. We don't actually render client components. We only inject these, or like this is like React, right? Like it's not something in Next.js. This is something that React does. It will inject those references to client components in the RC payload. And then what you get when you're rendering to HTML is that it will require those client components, render them to HTML as well. And that is very similar to what you get in, like, say, the Pages writer, right? Like in Next.js 12, in like earlier versions of Next.js, what we did before was basically creating this. Here was the starting point was like a client component by itself, right? So that was like, you could say like a client component reference that we inject into React, and then like React would render that instead. So everything was a client component previously. And then in in AppWriter, you get server components as well. It's like this layer in front of that, basically. Something to mention here as well is that conceptually it's like two different processes, right? So you have the server components rendering, then you have the HTML rendering. But in practice, this is actually like a streaming thing. So it doesn't like wait for the RC to render to then like start rendering to HTML and then like sending it to the browser. It'll actually do them all at the same time. So if there's a chunk of work being done, like that is done in the server components rendering, it'll pass it to the HTML rendering. If that is done as well, it will start streaming it to the browser. And that's how you get the HTML streaming as well with server components.
Cool. Awesome. So the result of the RSC render is always called the RSC payload, whether it's being used to render the initial render or it's being sent up to help the client render navigations and transitions on the client.
Yeah, and it's actually the same payload as well. So depending on like, if you give it the same components, you would get the same payload out, and you can basically decide, do I want to render it to HTML or do I want to like send it over the wire to the browser and then like use the React in the browser to render it instead.
Okay, so the references that are the holes of the server components in the payload, it's the environment that knows how to find those. If you were streaming it or rendering to HTML on the server environment would use the reference to load the component from the server. If it was the client version would know to use the references to reference them that are loaded in the browser. But at that, both times that it's assumed that the component exists. Basically, I'm guessing.
Yeah, exactly. So under the hood, what it does is these references, like in the payload that you send, RSC payload, that will have like a reference to a component that is like needs to be loaded basically, right? So
Right.
this reference is like it needs to be loaded on the server. That means like requiring it on the in the browser.
Just
It
in
means like
time.
importing it
Mm-hmm.
just in time, and
Mm-hmm.
then um, under the hood, this all uses suspense. Even if you don't have a suspense boundary, right? So if you have a suspense boundary, that would uh, like be affected by this. But the default in React is like there's no suspense boundary, so it will like just wait on all the work to be done, basically. So like if it needs to load the code, that's totally fine. In case of rendering to HTML, like it can trigger suspense boundaries as well. Like that's a thing that's like hard to understand when you're first seeing it because like I can inject a suspense boundary, see the loading state, and loading state is entirely like server side.
Mm-hmm.
But then it's like streamed to the browser, like filled in later by React itself, and it's like the out of order streaming that React
Mm-hmm.
allows to do.
Cool. Cool. So the okay, awesome. That cleared it up. I didn't understand that. The payload is the render target for the RSC tree, and that payload can be rendered on the server, pre-rendered on the server, rendered to stream or HTML. Can also be rendered by the client. That makes a lot of sense. That's very cool.
There's like a part to this which is that the even though I'm saying that the RC payload is the same,
Mm-hmm.
in most cases it actually is not the same. Because the what we do as well is that we have this feature in the writer which is called partial rendering, where we basically like search for like we diff like what is the current thing on screen versus like the thing that is that you're navigating to, and then we basically say, okay, you already have the dashboard layout because you're in like slash dashboard. If I now navigate to slash dashboard slash settings, it's not going to render the entire like dashboard layout again. It's actually only going to render like that lower bound down.
Mm-hmm.
And that is something that we specifically like built into the Next.js app writer.
Mm-hmm.
It is like a Next.js thing by itself, basically.
Mm-hmm. Right. So sometimes you'll send up the payload is the same, but sometimes you'll only get part of a certain amount of it, a diff of it, which the client knows to
Yeah,
use to re-render just a portion of the screen. That's an opinion from Next.js that is being used to save re-renders and to not send as much stuff because you already have the header, you don't need to re-render it. But conceptually, it's still coming from that same RSC payload.
yeah. It uses the same APIs. It's just that
Mm-hmm.
like it allows you to be flex. Like the React APIs allows you to be flexible with what you're rendering, right? So
Partial
you can
tree,
pass it a
basically.
component, but you don't have to pass it a component. You could also pass it an object that actually has two different React components,
Mm.
and then those two different React components, you could use that as like more like because usually if you're fetching like a JSON, for example, from API, you can get like two values out or like anything like that. In this case, like you would assume like, oh, I can only pass one React tree, but you could actually pass as many as you want. We actually do this for like if you're navigating, we also need to render the new head, right? So
Mm-hmm.
what we actually do is the like the fetch that we do for a client-side navigation.
Mm-hmm.
That one has instead of like one hole to fill in the React tree, we actually have two. So one is the patch that I was talking about, right? So it's like a lower bound render of that like new page that you're going to, and then the other part is the head itself, right? So the top part of the head that is different between the two pages, right? So you in this case, like you would have generate metadata, for example, and the generate metadata would generate like this head, and that's like all part of the responses file.
Cool. And that's all possible with the React's APIs that they expose for this stuff.
Yeah,
Cool. So I guess one quick question I had was, do you guys use, is there any terms y'all use to differentiate rendering in the higher level abstract sense versus rendering as getting things to the browser, like to actually paint it? Because, we talk about like server-side rendering and pre-rendering, and then we talk about everything we just talked about, which is really when you render the RSC tree, it's about generating this payload. And then there's a separate question of how that payload gets painted to the browser. Um, so do you guys have any terms you use to kind of differentiate between those two? Or do you just know
Good
you're
question.
talking about like when you're talking about
Yeah.
server-side rendering or pre-rendering, we're talking about getting the HTML, letting the browser paint, that sort of thing.
Yeah. So for most of what we talk about, it's like internally at least, like the thing here is that generally speaking, like we're not concerned with the like the end state of like rendering in the browser per se,
Hmm.
right? So we're trying to make sure that like the rendering that we do is always like rendering the React tree to a certain state. After that, you just hand it off to like React rendering, and React rendering will like do the commit and stuff like
Right.
that, like all lifecycle hooks, things like that. So when we're talking about rendering, it's well, we do have this. There's a distinction between like the rendering, like RC, for example. So we do like I usually call it RC rendering. So RC rendering, rendering to HTML,
Hmm.
because that is like the eventual like outcome of doing the initial request or like generating static HTML. And then there's like rendering in the browser, but that's like mostly the way that we talk about it, because we're obviously like working on the router itself and things like that, is that this is like client-side navigations and like how that
Hmm.
like state is updated in that way. The part where we do the rendering itself, like that's all like handed off to React eventually. Same as like if you're building like a React app from scratch, and you're basically just creating a React tree in the end.
Right. So, okay, that makes sense. If you were to talk about, say, a static page um, in a new app layout, an app router app, and you want to end up with it statically generated, you would say this thing gets rendered to HTML at build time.
So that part in particular, like we call that static rendering. So
Static
there's like
rendering.
there's two concepts here, like it's static rendering, dynamic rendering. Those actually like map closely to like what you had in pages. So like
Hmm.
get server side props, get static props.
Hmm. Hmm.
In terms
Hmm.
of rendering, so like not in terms of behavior per se, but like in terms
Right.
of like the way that they're rendered. Most of them actually use the same like mechanisms, even right, like the rendering to HTML at build time, like that's exactly the same thing as it was in like for pages. We reuse all of that like
Hmm.
logic that we already wrote for that.
Okay, got you. But that's how you would talk about it. If you were defining static rendering, you would say it gets rendered to HTML at build time. And that's a way to talk about more of like the actual what's happening as opposed to the rendering of the tree into the payload.
Exactly, yeah. And like usually you wouldn't even have to reason about like how the tree is generated per se,
Right.
because in the end, like that's what you're used to already in a way.
Right.
Like the main difference with RC is like it's the same thing that you had with like client components that you had before. So client components in this case, like it literally means like the thing that you already had, whereas
Right.
like server components is the new thing.
Right.
Um, it also means like because it's new, it doesn't mean that like you can't use client components, right? So like
Right.
what we see often is that people are like, oh, I need everything in my RC, and
Right.
it's like really not the case, right? It's the synergy between the two. Like you use server components for something different than you use
Right.
client components for. And sometimes it's the same thing, like rendering some markup. But in many cases, it's like you use client components for interaction and server components for like your data fetching, rendering the RC pay. Like RC payload here is like there's like a serialized form of React, right? So it means
Right.
like that's how, but like that is why you don't have to send all this code to the browser per se to render all of that. So the inherent benefit of using RC is like you're shipping less code to the browser, but really the way that it works under the hood is like you're just rendering or like when you're working with it, it's like you're just rendering a React tree. The only difference is that now it's serialized,
Right.
almost like you're saying, it's almost like a JSON API in a way, where
Right.
like you Like previously you would have to create like an API endpoint and like basically say, I'm going to render all of this like to HTML or something like that and do like dangerously set inner HTML of that particular HTML that you generated in order to achieve something like that. Whereas now it's like, I'm going to render a React tree. It works in exactly the same like way that I like used React before. The main difference is that I can't have interaction because obviously the server doesn't have state for this particular like request, for example. Um, and then you pass the eventual outcome of that into a client component with props, for example, to get more interaction. Or you don't, and then like you don't have the client components, and it's just sent to the browser as is.
Yep, nice. And just to make extra sure I'm clear, the payload has no knowledge of any server component at all. There's nothing about any server component in the payload, which is why if you look at the component tree, I mean, it makes sense, but when you first start doing it, you might be like, oh, here's my page. I rendered it. You look at the React component tree, there is no page because at that point it's been rendered away into just the client tree.
Yeah, exactly. That's why, like in React DevTools, you only see your client components, and actually, I haven't checked this, but like potentially also the p tags and things like that that you're
Right,
rendered as part of the like the tags that you render as part of the RC as
right.
well. Um, However, I'm not sure if that is like the eventual outcome here. Like it might be that like for development, we end up like building something where we can actually highlight that this is part like was rendered as part of this particular like RC component. But as of right now, this is not the case, and like something for exploration in the future for sure.
Cool. Awesome. All right, that was super helpful. Okay, I think next it would be good to talk about basically this is the other main point I wanted to cover with you was um, so the caching stuff in Next and React. I think less important is like the details of where things are right now, and more important again is this mental model because uh, I saw on Twitter you talking with some folks about it, and something you said was, with React, we going back to the beginning, it was like this top-down re-render and throw everything away and just re-render every time. And that was solving problems at the time in UI development with things not being in sync in the screen, stale portions of the screen not agreeing with data that was just updated. And React's kind of solution to that, which relied on like the virtual DOM, I guess, was a big part of it, was just say, let's just re-render everything every time anything changes. And that solved a lot of problems. And that one-way data flow from the top down, which enabled that, was something that we all learned as we learned React. And so moving away from solutions at the time that were like two-way binding, surgically updating parts of the tree that were lowered in for performance reasons or for whatever, led to these hard to understand programs, led to bugs. And now we were doing this top-down thing, and it solved a lot of those problems. And you were talking on Twitter how some of the new mental model for building an app with the app router, or even just with the RSC paradigm in general, the architecture in general, it's a shift. You said it's a shift away from thinking about top-down by consciously thinking about lifting up initialization work to the topmost component. And you said it's shifting it more to always do the work once per request, no matter where you call it. And it's still, but you said it's still about composition, which is really the important part here. And it reminded me also of something, I forget who said this, someone on the React team. It might have been Sebastian, who said a big part of RSC, the architecture in general, was how can we bring the benefits of Relay to the rest of the React community? And I feel like that unlocks something for me too. So maybe we could talk about that again, not talking about any of the specifics APIs, but just the mental model that now that we're doing work on the server and server components, the kinds of things that we couldn't do in React components before, how we still, what is the right way to think about that? And what's the React model here? If it's not re-render everything from the top down, you mentioned there's segments that don't change and we want to save work there, but there's still some piece of it that is important, I think. So maybe you could just reflect on that.
Yeah, definitely. So this was in particular around like React's new cache API, which uh, due to like unfortunate circumstances, like personally, I would have called it like memo. But as you know, like there is a memo API already.
Mm-hmm.
There's a use memo as well, and they
Mm-hmm.
do like completely different things, right? Like use memo, and it's for like in component caching of the variable. Memo itself, like React.memo, is a way to do like basically like introduce this like basically pass a component into it, which then like does memoization of the component tree when the props don't change. And then there's cache now, which is like it might sound confusing because like kind of the same thing, like memoization, caching, like not exactly, but like in the React sense, like when rendering here, it's like it's more like memoization in the like in the same request. So you're not caching something to a database, like writing it to Redis or something, and then like getting it back later. You're really just saying every time I call this function in the same React tree, I just want to get the value out. And the idea here is that you pass a pure function to cache, so that you always get the same like value no matter what like arguments you pass in. So if you pass in the same arguments, you always get the same value. And in doing so, this basically means like no matter where you call it, you can always get the same data without actually redoing all the work every time. However, this is a big shift away, like, well, not away, because like this is still useful for in the browser, right? So like when you have a um, a data fetching library that like runs in the browser in like client components, or if you use Redux or anything like that. Um, because really this is about deduping and like deduping work in the same request and making sure that no matter in what order your components render, that same like data fetching code always runs, even if you didn't like the problem here. Let's start with the problem. So the problem
Mm-hmm.
is, what if we start rendering only that one component that you wrote instead of rendering the entire React tree
Mm-hmm.
for that page? And as I was explaining before, we actually already do that, right? So we already only render the segment that changed instead of the entire page. If we build it in a way that you had this like global like passing data from like the layout down to the page, for example, it would not have been possible because then like we have to send all the data that you fetch during the layout to the browser as well, so that once we like start rendering the smaller slice of the page, we then have to pass all the data from the server to the browser, and then from the browser on the navigation request back to the server. In order to, because all the requests are stateless, right? So you like could get a completely different server that's servicing your request when you do another like navigation. So in order to keep this all like basically like easier to understand and like not have to send all this like extra data over the wire, which you probably like in most cases you actually don't want to send over the wire even because like could be sensitive or it could be like a massive payload, right? Like your entire blog post or something like that. And then you would want to send it back as well because like that's just like continuous overhead. So instead, the model is driving you to actually do the right thing, which is memoizing your request. And the only way to do that is by like React having knowledge of memoization within the same request, which is why Cache API exists.
Mm-hmm.
Because
Mm-hmm.
then you can basically say, okay, this like in the same request, we're not going to redo all this work
Mm-hmm.
while rendering in React. So that's like one part of it, and then like basically this is like I was saying in the tweet, it's like it's a big mental model shift because like even if I like wanted to start building an app and I would set everything up myself, so I wouldn't use like SWR or React Query or anything like that. My initial way of doing things would also be like, I need this data like globally available to all the components in the app. I'm going to put it at the very top and I'm going to
Right.
pass it down to everything
Hoist it to
using
the lowest
context, for
common
example.
ancestor, basically.
exactly. However, that actually introduces like a dependency on that data always being there, right? And that, um, like was explained, like that doesn't exist in like this partial rendering world. So um, basically, what this means is that like now you can compose React server components. I can basically like render the same component like 6 times across the entire React tree of the RC rendering, and it would not cause it to do 6 requests.
Hmm.
And it's mostly to allow you to like be able to compose these components as well.
Right.
It also helped with like there's another part that I realized later, watching a talk that Malte, the CTO of Vercel, gave at React Summit, which is that this also optimizes for this other part of maintenance of your application, which is that it allows you to delete code as well, or like
Hmm.
decide to branch off your code and not
Hmm.
run all this data fetching logic
Hmm.
when the page doesn't need it, right? So what I would
Right.
do before is like I would go and add like a global context. And on this global context, I'm going to say, this is all the, like I'm doing like 6 data fetches maybe, and these are required at this point in building the app. And like probably they're going to be required in like a year from now. But in like 2 years time, like someone else joins the company and they're like, oh, this doesn't actually make sense. I'm going to consolidate these 6 requests into the single API.
Hmm.
And then they do all that work, but then you realize like, oh wait, there is this other like place still that I have to like do this request as well. So you can't do this change,
They're
and we can
decoupled.
get rid of like some of these requests as well, even though
Right.
like they're the components have been removed, for example, right? Like that use
Right.
the data, and there's no way for you to know. Okay, it's like that data was always it
Depended
was just
on.
always globally there, right? So you
Yep.
didn't know if it was deleted.
Yep.
So it's like the point being that like this also optimizes for code deletion in a way
Yep.
where like I can remove my component and I can know that like now the app doesn't actually do this like extra data fetching as well.
Yep. Okay. Very interesting. A lot there. Maybe I can say some of it back to you to make sure I
Sure.
understand it because I think that was very, very helpful. Um, First, I think the point about cache versus memoize is good to understand because I didn't understand it until you just went through that. So you're saying that the React cache is really more similar to memoization in other languages. What this made me think of is in a Rails app, when you get a request, let's say you get the current user and you have a current underscore user global method, and you want to be able to check the current user in the controller, and then maybe later on you want to check it somewhere. That current user function that comes with Rails and like an auth library, let's say, is memoized, meaning it's expensive the first time you call it. So it's memoized so that the first time you call it, it connects to the database, fetches it, and then hydrates some Ruby object in memory. Then the next time or any time after, if you call current user, it just returns that object in memory. It doesn't go through the expensive connection again. That's usually what we mean by memoization in other languages. And that's kind of what you're saying is the motivation here. In the same way, you could have
Yep.
a current user function and it's going to be using the React cache, but that's really what's happening here.
Yeah, exactly. So you would write a like get user, for example, or like get user session or like
Yeah,
a
get current
particular thing
user.
that's like it's in most cases always a getter, right? So
Hmm.
it's not really the set case but a get case
Hmm.
where you basically say, okay, I'm going to say like, okay, this thing is always going to be the same no matter where I call it in the same request.
Hmm.
And that's good for other reasons as well besides performance, also like consistency of the value. So like
Hmm.
maybe you do this like data fetch in the header and then like you do data fetch in the like layout or like in the like lower layout or like on the page itself. You actually wouldn't want those two to be inconsistent as well. Like you would
Right.
them to be the same. Whereas like obviously, especially in larger apps, it could be that someone's making changes to the data continuously,
Right.
and then it would change out from under you, like in between the fetches as well.
Right. 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 Yep, that makes sense. Okay, so I like that. It's kind of thinking about it as memoization in the larger sense, not like React memo, but it's that is how the cache works. And then kind of for your other points, I think it's interesting to understand how it lets Next, re-render partial segments without having the dependency on the top-down data structure. But I think the easier way, at least for me to relate to it as an app developer, is what you said. What people are already doing with things like React Query and SWR and Redux. I don't think you have to make a strong argument to React developers these days about the benefits of those libraries, right? And those libraries came about even though React is based, client React, let's just not even talk about React server components. Client React is based on top-down render, and it always re-renders, and the data is consistent. But those libraries let you interface with external stores, right? Things like SWR and React Query. And those use query hooks that you get from those make certain things very, very easy. One way data propping from one way data passing from the lowest ancestor is still a core part of React architecture. But when you have something that is more inherently global in nature, like the current user or a query that represents what the server side state is, that's like a single source of truth, and you want to pass that to each component, having all those middlemen components with prop passing is what led to the solution of something like a hook that references a global store. So I think anyone who's using data fetching libraries like those and has a use current user hook understands the benefits of being able to drop in a little avatar, use the current user, see if they have access to this thing, and have that be coupled and encapsulated in the component and not having to have the parent have knowledge of that. And I think that's kind of what you were getting at, right? This is still it's still the same React architecture, but there's a situation where these things are a good solution because they are valuing the principle of composition basically over this one-way data flow. Like the one-way data flow is a way to help us make sure we make predictable applications and the thing agrees. But really the most important part about React is composition. That's the component, right? And so co-locating the needs of this component, the data dependencies with the render output, being able to do that with hooks solved a lot of these problems. It also has the benefits like you described where you can delete it and you don't have to go and see which secret place it was getting the data dependencies from. And now you're saying this memoization, this cache lets us do the same thing on the server. And so you're actually going to be able to take more advantage of composition in React if you do the same thing in your server components. You co-locate the fetch with the part of the tree that needs it. The caching is what lets you do that in a way that is like reasonable from a performance perspective. But fundamentally, that is the benefit that app developers are getting. Is that kind of more or less right?
Yeah, that makes sense. It's conceptually like in the way that you write the code. So it's not in the way that's implemented, but in the way that you write the code, it's very similar to what SWR does. So you just write the SWR and like you provide a fetcher. And if the fetcher is the same, it's always going to use the same the same cache value, right? So it's almost like this memoization, but for the client side. And obviously in the client side, there's more to this, right? So it's not just we're going to like reuse the same like cache value because the cache value could also change in the browser. So you have this like mutations basically, and like how do you override the caching and things like that. So that brings like another part to this, which is like there's React cache, but there's also a Next.js data cache now, which is like another layer on top of just memoization, basically, where you can have this, like I want to write values to a particular store that is actually shared between all requests as well. So that like you can make your site faster because like the caching is might be faster than going to the database or going to your external API. You can make sure that that is always reused across requests as well using this data cache.
Got you. And that would be a cross request, whereas the React cache is, again, more like memoizing current user in Rails on a single request. Got you. And does that tie back to whenever I heard, I think it was Sebastian, but Relay did have a similar benefit. It encouraged you to write the data fetching code. I never used it, but this was my understanding. It encouraged you to write the query with the component. If you had the same query in multiple components, the compiler could turn those basically into a single shared thing, that a function that could be memoized. And that way, again, you get the benefit of the co-location of the data fetch with the component that needs it. You get the deduping, so you don't get punished for that. And then you get the deletability. If you delete it, it just goes away and you don't have to remember where the implicit dependency is.
Yeah, it's fairly similar to Relay as well. I haven't used Relay that much either. One of the things that Relay had, like, there's a lot of similarities between like Relay and React Server components as well. There's good reason for that. Like, the people that worked on Relay also worked on RSC. So Joe Savona, and basically, like, Relay has this like concept of data, like doing data fetching, but also querying components. So you can get like references to components back as well. So you can say basically say like, I want to do this query for like a post, but then like I also want to get like the comments component back only if the comments exist or something like that. So it actually is like an optimization there where you can say, I don't want to get the comments component or like always ship that as part of the browser, like the browser bundle. We actually get it on demand as it's needed based on the data. And it might sound familiar. That's like very similar to what you do if you write this same, like, basically it's making this like data layer part of React itself, where you can say, I want to, like, based on some like of my own conditions, right? Like not a like GraphQL API or anything like that. I want like to have a particular condition here that is I fetch the data from a database. I'm saying a database continuously, but like it doesn't have to be a database, right? Like it can be external APIs as well. It's just that like previously it wasn't possible to do this database thing, so that's why like people mention it quite often. It's like you're now back to this. I can do like any data fetching I want instead of like I need to build an API for the particular data fetching as well. Um, so really, like you fetch the data from the database and then you get the result back, and the result's empty, for example. Now I can say in my component, like comments.length is 0. Let's not render this component. If you don't render the component, it's not going to be shipped to the browser as well.
Right. Right. And that's even more of the composition point. You know, how if you had a situation where you have to load the data up front and then you ship the code to render separately, now these things are together. They can be co-located within a single component. So you can write business logic is what you're saying basically, right? That says post.comments is not there, so we don't even
Yep.
need to render the comments component, something like that. And it's just bringing more of those benefits since these are co-located. Quick question, just technical question about that. In the app router, the client side bundle is determined from the ES6 import graph, right? So if you had a page that conditionally rendered a comments component, it would be in the browser code, right? If even if the runtime data said we're not going to render it, because there's a state where it could be there. So the route split bundles are generated from the static ES6 graph, right? So as soon as you import comments and render it even conditionally, potentially in the RSC, it'll be in the client bundle for that route, right? And you'd have to use something like lazy if you wanted to lazy load it.
Um, as of right now, that is the case. In the future, it won't be.
Oh wow.
So the thing is that the entire way that this is built is that um, React, like we said, we have this client references, right? So as of right now, you basically get like client reference going to like it's this particular bundle that you need to load. However, like most client references will reference the same bundle.
Mm-hmm.
In the future, and this is why like we're building TurboPack as well, and like doing a bunch of stuff around bundling. We're going to create more bundles with like a smarter like algorithm for creating the split chunks, basically, right? Like where we split the different bundles. So at that point, like at that point, you would get only the like. It kind of depends on like what the size is of the component as well, because like
Mm,
sometimes you would want to, like, say it's 1 kilobyte or something, you might actually
mm,
want to ship it like this extra bit, just so that it's cached in the browser and you don't have to
right.
load it on demand in like a majority case. But basically it's all set up to be able to do that, right? Like you're rendering some component on demand based on like its own browser bundle, or like own JavaScript bundle in the browser, and it can load that, and like that is all, like the infrastructure to do it is all there. The bundlers are not at that point yet,
Hmm.
and that's what we're working on right now to get to a point where we can do this in a smart way where we can optimize the browser bundle more.
Cool. But you wouldn't, the mental model and the API from the app developer's perspective wouldn't change. You still use client when you want to start using features, and then when you
Yeah.
import client components and render them from server components, that's where you guys can optimize that over time. But that stuff's not changing.
Yeah, it's really the like the way that you write the components is exactly the same. It's purely a bundler perspective,
Hmm.
like a bundler concern that we need to tackle basically.
Very cool.
And this is purely like if you don't render it, right? So like this is only the
Right.
case where you
Right.
say, I'm not going to render the client component.
Right.
Um, so like in practice, it doesn't have like a massive like win per se. It really depends on what you're building. Because what you see instead is that previously what people would do is you would build this like one like switch component that basically like based on some, like what we've seen a lot is like you're using a CMS and the CMS is deciding what the layout is.
Right.
So you have to provide like a list of components,
Uh-huh. That
and then
it
you do
could
like a
be
switch
rendered.
statement on like when
Right.
do you, like I want to render this one, I want to render this one, I want to render this one, or use like an object and then like you pass in the value. The big difference with RSC is like now I can move this to the server instead.
Mm.
So I don't have to send this, like this is all the components that are possible,
Mm-hmm.
and switching them. Instead, you can say I want to render this particular component or that component, and then like if they don't use like if they're not client components, you would get like an instant win here. And otherwise, it's like when we get to this point where everything is split, you get like a win there as well.
Right. Cool.
But in the end, like it's not like it's never worse than what you get with pages today, basically.
Right. Right.
It's like important
Awesome.
to know that like a lot of what we have in AppWriter is like it's not per se a like a massive performance win, for example. If you like you can basically like move your Pages Writer app or like a single page on Pages Writer to AppWriter, and then I saw that some people assume that like magically it would get faster. It will magically get better core web vitals because of like some other like improvements that we've done to like the way that the router works, the way that streaming works, the way that you have suspense boundaries now. You can do all these
Mm-hmm.
like other optimizations. But if you like move them one to one, the biggest difference you're going to see is like the bundle size by default is less. And
Mm-hmm.
why is that? Not because like your app is now smaller, but it's because Next.js is now smaller. Because like
Mm.
because all of this work that React now does, um, we were able to remove like quite a bit from the Next.js like client side runtime as well. So there's a like there's this misconception that like you would get instant performance win, whereas like it's more like you get the performance win once you start moving some of your heavier components, for example, like say you have like a markdown to HTML generator or something like that. You move that to the server instead,
Right. Right. Cool.
and it also means
Um,
that you get to this point um, where you can say like I get the same app that I already have. I'm happy with the page starter app. It's more like I can now start optimizing more, or like start leveraging some of the newer APIs, start leveraging React transitions, start leveraging suspense a bit more, leverage the new app writer, and like app writer is solving like 60 different issues
yeah.
that the pages writer has, like all like tiny tweaks or things that people were running into with the pages writer that weren't able to be fixed in app writer, or sorry, the other way around, like we couldn't fix them in pages writer.
Mm-hmm.
They were running into this problem where like say back navigation with get server side props like wouldn't preserve the right like scroll position. Like you move to app writer and now you have that particular like fixed because we architected around these like we basically took that list of like, oh, these are the known issues that people are struggling with the most, and we're going to fix them in the app router.
Right. The nested router itself set aside server components, set aside caching, just the nested router features of the app router solves a lot of problems. That's how we think about it. I think that's a good kind of takeaway is um, app router is backwards compatible with pages. You can move your app and it's compatible so that you can get on it. You should expect about the same behavior, but now you have this entirely new set of capabilities that you can take advantage of and start moving parts of your app that couldn't do things you wanted to in pages or can be even better when you do something like you said, move a markdown render to only the server. So, yeah, I know I think that's the right way to think about it for sure. Um, I think one more question I have around the caching stuff, again, from the mental model. I like what you said. I think basically one takeaway here from, again, high level mental model perspective is all of these pieces are in place to, like you said, encourage people, nudge people to do the right thing, which in this case is co-locating the data requirements with the component that needs them. That's what allows Next to do things like render parts in parallel or only render the parts that need it. There's no dependency from the root component all the way down the tree. That enables all sorts of these optimizations. But really, from your perspective as the app developer, it just makes it easier to work with in the same way that React Query and SWR make client apps easier to build because I can have a component that renders a user by calling use current user, and I can render it in several different routes. And the route itself doesn't have to have knowledge of the data dependencies for it. It's encapsulated, it's more composable. That is really the goal with all of this. And so if people are used to building server-side pages where the route is the entry point, you load all the data, and then you pass it down to a tree. As that gets more complex and you refactor into shared components that are used in multiple places, co-locating the data with the components that need them is actually what the goal is for all of this to support that type of development model, that type of architecture.
Yeah, definitely. And it's like this adds like another layer though. Like you get the data cache, like I said, but also this means like there is a line-side router cache now as well.
Mm-hmm.
And the main thing to note here is basically if you've used like SWR or React Query before, you know that like every time something changes, so I'm doing like a fetch to the database or like to an API to update the database. I have to call like this mutate API, right? Say I'm going to like update the user, for example, because like something changed. Um, like with RC and AppRouter, that's like mostly the same, right? Like you need to tell Next.js, hey, something has changed because otherwise we're going to stick like to this list of components that we already like got from the server. And that's where like router.refresh comes in. So you can say like you call router refresh, it clears out all the client-side caches. And it will also like there's other APIs using like server actions, for example, where you can say revalidate pod or revalidate tag to basically say this particular tag needs to be updated, but that also means like the client-side router gets invalidated as well. And that's important because like otherwise you get like back forward navigation that's so cached and things like that.
Yep, that was going to be my next question. So I'm glad you brought that up. Basically, given this world where components have their own data dependencies inside of them, and they're building together this tree, they compose together in this tree, which lets Next render partial things that haven't changed. Then you do have the situation where, okay, we have hi Sam, in the header of my website, and then now I'm on some nested page that lets me edit my name. And let's say those are the same piece of data. So maybe we can talk about it like this again, the mental model. So if you were starting in a Rails app or a PHP app, a server-driven app, The user has an expectation that when you load a page, you click on an issues page of GitHub, you're looking at a snapshot basically. And you don't really expect that page to change until you either click the refresh bar or you click on an issue, let's say. Then we had JavaScript apps come along, and one of the benefits of them is that we can make them update without the user having to navigate, right? And so flash forward to something like SWR, which is kind of like a fulfillment of that idea, where it's kind of you have both of these things. You click around, and as the user clicks links, they get new data. Maybe they even tab back or wait 5 seconds and SWR refreshes it. So there's different
Yep.
ways that the data can change. So in an app directory app, in an app router app, let's say you render the user's name, hi Sam in the header, and then I'm on a nested page that has a form that lets me change it. From a mental model perspective, are we supposed to think of, okay, the baseline is if I'm clicking around links, let's say I save it. If I click a new link, should I expect the new name in the header to happen because of a navigation? If I submit a form, does it happen? If I submit a form with a server action, does it happen? Basically, there's ways the data can change in something that's already been rendered, either via an action that I take on my browser, either a navigation or a form submission. And then there's ways it can change somewhere else. Maybe somebody else updates it and I need to refresh. So maybe we can talk about those two and how you think about those two things and how the
Yep.
app developer should think about refreshing parts of the tree.
Yeah, it's something I was writing a document about. Like, I'm going to post that probably later today or tomorrow, which is basically a reply to like an issue around one of the caches that Next.js has. So like people had a lot of feedback about like what is the like why did you add this like 30 seconds caching when I'm navigating basically for dynamic pages. And I was basically working on like a more thorough reply to like this large issue of like people basically like giving feedback on like, oh, this doesn't work for me. I need this other like way to do things, basically like opt out or something like that. Um, but obviously there's like a lot to consider here, and like there's layers of like partial navigation, for example, back forward navigation, like you were talking about, as well as like what do you do when you navigate between multiple pages. It's like there's two parts to this, which you already mentioned actually. It's like one is actions I take, right? So things that I am doing that should invalidate the router in a way. So, well, so most people actually don't think about like, oh, I need to invalidate the router. It's like I call mutate or like I dispatch a Redux action or something like that, right? You fetch data or like you do a post request, like you client side, right? You do it like on click, like on submit, and you say, I'm going to fetch the API, and that's going to inject like or put requests where you say like my name is now Tim, for example. And after you do that, you basically say like in like if you're used to like building SPAs, you basically say, okay, dispatch this action with the new username or like with the new user object. And that would then like update the entire like the global state that you have. Like that could be through Redux, but it could also be through any other like library that you're using, or like even like use reducer or things like that. Um, so once you have that mental model of like I'm going to fetch the API, you get a response back, and then I'm going to update the UI with the newest data, right? With RC, there's like a shift of that where like I got the data on the server instead of like in the browser, so I don't have access to this like Redux store, for example, or like this state that I have in the browser. Instead, it all lives on the server, right?
Mm-hmm.
So what do I do when something changes?
Mm-hmm.
So there's like two ways to do this. So like one is, and that's the current like stable way to do it, which is basically saying I'm going to fetch the API. So like do the put request, say my name is Tim,
Mm-hmm.
and now I say I want to reload the page, right? Rather than refresh, which basically means fetch the server again and basically say, okay, give me the new data, right? So give me like re-render the entire page. Like there's a important difference here. Like navigating is like partial navigation. Refreshing is never partial navigation. So it's always
Mm-hmm.
going to send you back the entire page.
Mm-hmm.
The thing at that point is like, okay, now my layouts have been updated.
Right.
If they did like it showed your name as well, right?
Right.
So now it's saying like hello Tim instead of hello Sam, right?
Mm-hmm. Mm-hmm. Mm-hmm.
Um, so that's like one part.
And that would be like calling mutate on the SWR store, let's say. You just say mutate, no
Exactly. The main
arguments,
difference
you're
is
clearing
here.
the
Yeah.
store, and you just refresh it, basically.
Yeah. Which is like that feels weird, right? Because like now you're looking at your like network tab, for example, and you're like, I'm doing this fetch to the server, the data comes back, and I'm doing this fetch to the server again to get the new data. And that's where server actions comes in. So like server actions is the way that like you're going to do most of this type of mutation is what we're expecting.
Mm-hmm.
Right now it's like we're still working on it, so it's
Mm-hmm.
not in the like you can already use it and try it out, but it's not stable yet.
Mm-hmm.
But like once it's stable, we're expecting that like most of these like types of mutation that you're doing would actually live there instead. It doesn't have to though. Like it's entirely like optional if you want to do it, but then you would call write refresh or maybe like some other API that we add to the client side router as well in the
Mm-hmm.
future. For when it's stable, the basically what you would do is you would create a say like a form, and you would pause the server action. So you already like covered server actions a bit in your previous episodes. Basically, server actions is like a very low effort way to create like an API endpoint in a way, where you say use server in a function, and now you can pass that to like true server components to a client component, which then like similar to a client component reference, like you get a server component a server action reference. And the server action reference basically like React knows how to call that like API basically. So you basically like provide React in the client side a function called call server, and call server is called every time you like submit a form that has a server action reference attached to it, for example. Um, so now what you can do is you can do this. So let's say we only replace that part, right? Like the updating part. So now you pass this server action to the client component, or you import it, which is also supported. And then you basically call that server action instead, right? So now you have two requests. So you do this request that's like basically like low effort, like route handler, where you say I'm going to update the data in the database, but I'm still going to call write refresh because like it's like the first step here.
Right. It's like the high level way
So
to
now we
say,
have the
I know
same thing that
something's
we had before,
changed.
right? Yeah.
Yep.
Yeah. So it's the same thing as before, but now you
Mm-hmm.
have like await server action basically,
Mm-hmm.
and then like await writer like, well, yeah, like you call writer to refresh, you don't have to wait that one.
Mm-hmm.
Um, so now you get the exact same workings. That's all there. You have two requests, but now really like we still have the same problem, right? We're doing two fetches, and like why can't the server just re-render in the same request? So that is where revalidate pod and revalidate tag come in. So revalidate pod and revalidate tag are basically like a way that you can say, I want to rather the refresh, I want to get this like rendering of the current page that you're on. As part of that same round trip that you're going to the server for the server action. So basically, instead of saying rather refresh, you remove the rather refresh, and now you go to the server action, and in the server action you say revalidate pod, and then you provide like the pod that you want to revalidate or like purge from the cache. Or you say revalidate tag, and you can basically like tag all your fetches with the particular like tag that you want to invalidate. For the most part, I think like in the majority case, you're going to use revalidate tag actually, because it's like more like surrogate keys where you can say
I was going to ask
this
about
particular
that.
fetch is for the blog, right? So then you can say like, I want to like purge all the blog like data cache entries, and that would also invalidate the client-side writer as well as part of that. So there's like three things it does. It's like it's going to render the page, it's going to invalidate the writer cache, and it's going to like apply that new rendered page to the writer cache again.
Got you.
So then you get like in the same round trip, you update the database and you render the new page.
Right.
And it's like something that is really hard to do if you don't have this like end-to-end system like
Right.
what you get in Next, basically.
Right. So that's the server actions from React are the missing piece there, but coupled with Next and the knowledge of all the caching layers, it's basically if you were using Apollo, a lot of people who have used Apollo, again, similar to React Query, SWR, Apollo has a cache. And if you're making an update, you can clear the cache so it starts out fresh. But a lot of times you're making a mutation and you have more knowledge of which parts of the cache the mutation is changing. So the current user is changing from Sam to Tim. I can go in to the Apollo cache and update it so that the source of truth there is the cache and it's updated before I hear back. And then when I hear back, it kind of just no opposite. But the idea being you have a mutation, you know more about where this should change, what data this should change, and which components are reading from it. And that's why people do that sort of thing with SWR and Apollo, because conceptually they want all these things to happen at once. And so you're saying it's the same thing. Now it's all driven on the server, which has all these benefits, but with APIs like revalidate tag and revalidate path, you can get it all back. And so that's how you would expect if the user is taking an action that should change data, you're the developer, you're writing that path, you know which data is changing, and you can revalidate the user tag, let's say, and any component that needs it will get it as part of that same request, basically.
Yeah, exactly. So it's going to re-render the entire page
Mm-hmm.
automatically. It's like implicitly happening in the background. So you
Right.
don't even notice, like you don't call like next.render or something. It's
Right.
like you call revalidate pod and it
Right.
will automatically do it.
Cool.
Um, so that basically brings us to like that's all wrapped up, right? Like how do I do like I am making changes. Now it's
The
like,
current user is
yeah.
making a change.
So now it's like I am browsing the website, but Sam is in the in the back end making new products or something like that.
Mm-hmm.
Um, so you're like on this e-commerce store, you go to slash products. When do I see like your edits, basically?
Yep.
Um, so the quick explanation there is like there's two timings for this. So like one is the page uses static rendering. It's like the route uses static rendering. So like you basically say everything on my page is static, and you generate like basically we call this full route cache. So it's like you generate the full HTML for the page as well as the full RSC payload, and then we send that every time you request it. And then they can revalidate in the background, same as like what ISR did in pages. But really, it's like that is like let's say the static case basically. So like static means we're going to cache it in the client-side router for 5 minutes, unless you call router refresh or you call a server action that does revalidate pod, because like I said, those clear the client-side router cache. So really what you do here is you go to this products page, and now I like for 5 minutes, if I don't refresh, right? If I do a manual refresh, it's obviously going to clear the client-side writer cache because like you don't get the same JavaScript instance there. But the case here is basically like I start navigating around, come back to it after 5 minutes, and now my like page is the latest basically. And this could be like if you refresh, you already saw the latest like update that you made because you called revalidate pod in like a route handler, for example. However, the like that 5 minutes mark is actually like a lot better than what you had with get static props in pages. Because get static props in pages was like we're going to cache it forever. Good
Right.
luck.
Right.
Refresh and then you see the latest thing. In AppRider, we actually gave it like a limit, right? So 5 minutes is a limit. Now the difference is with dynamic. In the dynamic case, it's like you get 30 seconds instead. So what that means is like you go to the page, and then you leave the page, and like after you leave the page, like 30 seconds after that, it's gone out of the cache. So why 30 seconds? Like it's kind of an arbitrary number in the sense like we have to pick like some number, and 30 seconds is like sort of a time between like if I am going to navigate very quickly between other like tabs, for example, because you can also build like, tabs using parallel routes or like some kind of like UI similar to what Vercel's like marketing pages have, where you can like navigate through like this list of like 5 different tabs that you have like in the header. For that one, it's like you click on the link and then you click back on the same link that you were at before, like you instantly see that page again. That's like why this 30 seconds exists. Especially like on slower networks or like slower phones, things like that. This actually helps UX quite a bit because you don't get like more spinners basically. And it doesn't cause like extra layout shift and things like that. Now for so that's like the 30 seconds cache, but this can also be invalidated using rather refresh or like revalidate pod or anything like that. So I go to the page, I see the latest product that you added. I go to another page, you added another product. I go back, I don't see it, but like in 30 seconds, I do the same action, then you do see it. And that is really like the that's all there is to it, basically.
Mm-hmm,
It's like 30
mm-hmm.
seconds, that's it. We're still exploring like, does this 30 seconds, like, do we want to allow you to change that so to
Mm-hmm.
like be lower, for example, like a lower bound, like 5 seconds or maybe even 0, where you always navigate and you see the latest. But that does mean that we need to figure out like what is the thing that people are expecting, and that's why we like why I'm writing this like post on like
Mm-hmm.
how does it exactly like every single like interaction work, because at this point what we're seeing is that there's also confusion around this like I'm making an action, like I'm making some change myself, and that
Right.
doesn't invalidate the router cache.
Right, because that would be that would
So
be an error in their code from the perspective of if you are writing code in the application that mutates, there's a known path of mutation, you should be signaling to the system that this invalidates all blog posts or this invalidates these routes. That's the way to solve that
yeah,
problem. This is a different case where there's basically a server-driven change that's not coming from the current user, and the
yeah,
question is how to get that data into the user session.
exactly. Yeah. So and there's ways to do it. So it's not like I can't show you the latest version of the route. It's more like you can get the SWR behavior, for example, right? Like the
Mm-hmm.
focus, like on focus, do router refresh.
Mm-hmm.
You can also do like in use effect with like the path name passed in. You can say like use effect router refresh. That's totally fine as well.
Mm-hmm. Mm-hmm. Mm-hmm.
So in that case, like the component mount or like the new page mount, and then at that point you say let's get the latest data. That does cause like some UX that's like not super ideal, like but it's the same UX that you get for SWR
SWR.
V-theory,
It's
where
literally
like
it's literally
yeah,
stale while
yeah,
revalidate because it's going to render
yeah,
immediately from cache, and then on the second frame, the effect will trigger a re-render, and so it's
yeah,
just like SWR.
yeah, exactly, and it's like a component that we're going to document as well. Like
Cool.
it's fairly simple to write it yourself. It's like just
Right.
like use path name, use
Right.
effect, pass the path name in the dependency array, and call router refresh, and then like it will only call it when the path name changes.
Mm-hmm.
Um, but we have a component for that. Like we wrote one for the Vercel like dashboard, which also used the still revalidate behavior.
Mm-hmm.
So that's
Cool.
like still coming soon in this like post that I'm writing. Um, so then there's the last part to this, which is like back forward navigation. So back-forward navigation is slightly different, where that one doesn't have a timeout, like a particular timeout. What it actually has is it has a like it just keeps the components around, basically like the segments that were rendered. So from the previous page as well. You can invalidate that using rather refresh, for example, or revalidate pod. Like it's the same thing that's invalidated like with all the other ones.
You said
But
you
this
can or
one,
you can't.
you can. So like if you
Okay.
call rather refresh, it will still be like cleared out as well. Um, However, that has some trade-offs, right? Because like the reason that we keep this around is that like if you click back, you always get this page immediately, and the reason that we need to render it immediately is that scroll position depends on that actually. So like
Mm-hmm.
in order to get the scroll, like the native browser scroll position, you need to like get everything rendered in this like particular like window of time. And
Yeah.
generally, like even blocking the main thread like as part of that as well. So we had to make a change in React in order to make it work really well, which is like we basically like added this thing where if a React transition is called within pop state, it will actually like bill out of doing concurrent rendering. It will actually be a synchronous render instead, only for pop state, because that's like a user interaction as well. It's like similar to onClick and
Mm-hmm.
stuff like that, where you click a button, so it needs to do something synchronous,
Mm-hmm.
basically.
Mm-hmm.
Um, so because we do that now, and like this change in React landed, if you click the back button in AppWriter, you always get the right like scroll position, which is like this is this whole thing in like Pages Writer where like scroll position would often be not exactly where you wanted to render. This has multiple reasons, like get server props had some particular behavior around like refetching. The get static props didn't really have this problem, but then like you could never invalidate it, so it would never like actually get cleared out. And now we have this thing where if you click back, you see the previous result, so like it doesn't do a new fetch or anything like that. But it actually is more like the back forward cache in the browser itself.
Mm.
So it's like very similar, like you get what you were viewing already. Um,
Interesting.
yeah,
Question. So let's say you visit Twitter, you load the data in RSC, render all these tweets, you scroll down 2 pages, then you click notifications and you render that. And then you have a button that says like see notifications. So in my code, I say on click router.refresh. Let's just say I do that. And then I
yeah.
click back. So the home page is still in the cache or just the description without the data or with the data?
No, it's all gone at that point. So rather
Okay.
refresh, like the way to think about this is like rather refresh is the same equivalent as revalidate pod slash.
Uh-huh.
And that might sound weird, but like revalidate pod slash means I'm going to invalidate the slash route, but also anything below it.
Ah,
And anything below it is like all
everything.
routes, right?
Right.
Because that's the root of the project. Um, in the future, we'll have a more granular like clearing of the cache, where if you call revalidate
Mm-hmm.
pod slash notifications, for example,
Mm-hmm.
it would not invalidate the caches for like the homepage, for example.
Mm-hmm. Mm-hmm. Mm-hmm.
And in that
Right.
case, like the back navigation would still be the
It would
same.
behave as
And
you expect. It would be just like the browser
yeah,
does, where yeah,
yeah,
that's a tough one actually. This has come up since I've been doing Ember, where you think about you can ask a question. You know, you're on GitHub, you see, you know, 10 open issues. You click issues, you close one, and then when you click back. What should you see? You know, and different
yeah,
frameworks, even server side frameworks, answer this question differently. Um, there's one line of thinking that a browser should always show you the stack that was in history. So it should show you a stale page because that's
yeah,
what the user's trying to do. But then if you think about doing that on like a banking website, you click account, you deposit
yeah,
money, and then you click back, you're looking at a page that's stale. And the question is, does the user even understand what they're looking at? That seems confusing. And
yeah,
so I guess app developers should be able to have control over that because it's different for different apps, and that's kind of what you're saying they can do.
Yeah, so you get full flexibility on like
Mm-hmm.
what parts you want to invalidate in a way.
Mm-hmm. Mm-hmm.
And obviously, like there will be edge cases for that as
Mm-hmm.
well. And there's like ways to work around it. So like if you want like your back navigation to always be the latest, you can do the
Right.
same like trick where you do use effects
Right.
with write a refresh,
Right.
and then we'll do like a still or validate like behavior on back navigation as well. Um, yeah, so basically like that is the
That
two
covers all the
parts right
bases.
now.
Yep.
Yeah. The only thing here is like trying to figure out like what is this like if we allow you to disable like 30 seconds, for example, or like make
Mm-hmm.
it lower or things like that. No, lower is fine, actually. Like we could do that easily. What if you set nil, or like zero, basically? Like what happens in that case? Like do you get a navigation where it fetches new data, but like it's not going to get you new layouts, for example, right? Because like the
Mm-hmm.
layouts will not update when you're doing
Mm-hmm.
partial like rendering, because the layout will be the same between the two pages. Um, so it's really like figuring out like what is the right like trade-off, which in the end like mostly everything is a trade-off
Mm-hmm.
in choosing this behavior, but um, like in the end like you'll be able to build like an app that is like I read my own writes. That's another thing that we like spend a lot of time on for server actions, like that render after you make this database change or anything like that, and calls revalidate pod. That render is always going to get the latest value out of the cache. So out of the data cache, for example, or like no hit in the data cache, and then like it will fill it as well. Because otherwise, what happens is like you call like update my database. We start this render for you, but then like this render is going to return the old value, which also doesn't make sense. So like there's a lot of like small details that like fit together into this like whole model of like if I'm making changes, I call something from next in order to say things have changed, right? So this is like rather refresh for like client side code or revalidate pod, revalidate tag for server side code.
Right. Right. I think it would be interesting if you could disable all the caching layers just to understand, and then you kind of add them in. I guess from, do you have a way, an order in which you think of these things from your perspective? Let's say we remove everything, and maybe the first one is kind of like the client side layout stuff so that you don't re-render ancestors, and then it's like the cache, like the memoization stuff we were talking about. Does it kind of go from this, I guess, just quick, we can be quick about it, but like do you think about the caching layers as starting like the first level one, the first layer is the client and it moves back to the server? I'm guessing that's probably how it is, right?
Yeah, it's we actually made a very clear like I'm saying this myself, so
Comprehensive.
like it might not be clear to you, but the like in the new caching documentation in the like on the Next.js docs, if you search for caching or like in the sidebar click on caching, we made this visual where basically it shows like going from client to server, what happens if it's a miss, what happens if it's a hit, right?
Mm-hmm.
So
Mm-hmm.
in your case, like what you're explaining is like what if everything is a miss, right? Like if it
Mm-hmm.
didn't exist at all.
Mm-hmm.
So you basically go from like client side writer cache, so it's like the RC payload and like the spec forward thing. That's like all the client side actually. And then like you go to server side, right? So that you have the full write cache. Previously that was like known as like ISR or like this like particular like caching for Next. If that one doesn't uh, like if it misses basically,
Mm-hmm.
then at that point you basically hit the rendering, right? So now we're
Mm-hmm.
rendering a page. So we're
Mm-hmm.
rendering the RC payload to then like render to HTML. So that means like we're rendering. So like at that
Mm-hmm.
point you hit the memoization, right? So
Mm-hmm.
the
Mm-hmm. Mm-hmm.
React.cache API. So say like we hit the first one of that. So you do like fetch to your database or like your data store. You basically say, okay, we're going to hit the Next.js data cache now, right? So the Next.js data cache is like this key value store basically where we can like write responses to. So that one, if that hits, that basically means like you get a very fast read of the data. If that misses, then we go to your data source.
And that one is shared across requests.
And that one is shared across
Yeah. But the
request. Yeah,
memoization is not.
exactly. Yeah.
Cool. Got it.
Yeah. So the data cache is persistent, whereas
Hmm.
the memoization is in memory. Yeah.
That's more like thinking about Redis. Thinking about that like a Redis, basically.
Yeah. You can think of it as Redis, memcached, like thing
Hmm.
like that. That is like key value store. And like on
Yep.
Vercel, this is slightly different, where like we built this thing where the data cache, like Vercel data cache, is replicated across the world and things like that as well.
Gotcha. Cool.
Yeah.
Awesome. And then the full route cache you said on the server, that's like the dynamic, the static stuff. That would be probably
That's
more like,
like that's what you call static,
yeah,
basically. Yeah. So
static.
it's like static HTML, static
Yep.
RC payload. Yeah.
Maybe more like Russian doll caching in Rails, where you mark a segment of a template as being cacheable until this surrogate key changes or something like that. It's just a chunk of the HTML, basically. That's not about Redis and it's not about memoizing current user. It's like a separate.
So the full route cache is this is the reason why we call it full route. It's like the full rendered HTML.
Uh-huh.
So it's really like static page, like fully
Got
static
you.
HTML.
Got you.
Um, for what you're referring to, that's more like what the data cache layer
Okay.
helps with. So that
Got
one
you.
is like I can basically get ISR at the individual fetch level, right? So I can say
Uh-huh.
revalidate on this fetch is going to take like 10 seconds, whereas this revalidate on the actual like post content takes like a full day maybe or something like that.
Got you.
So
Cool.
similarly, you can now say like I'm going to do dynamic rendering, but I'm going to make sure that all my data reads are extremely quick by saying that the individual fetches here are now cached, right? Like my header is cached,
Right.
my like layers below it is cached as well. Yeah.
Right, right, right. Cool. Awesome, man. Hey, why don't we wrap up with just a few rapid fire because we had a few questions, but I think that was an awesome overview of what you've been thinking about, what you guys have been working on. Helped me understand a lot for sure. So does that sound good?
Yeah, definitely.
Cool. Um, just yeah, a few rapid fire questions. So first would be revalidate path and revalidate tag. They're not promises, so you don't await them, right?
Correct. Yeah.
So how does that work? Where you call them in the action, is that to let Next have more flexibility about the revalidation times and the schedules and everything?
You can actually call multiple. So if you call revalidate pod slash revalidate pod slash dashboard, like stuff like that, like you can do like six at the same time.
Got you.
And then the reason that like you don't await that, like in like you had rest.revalidate in API routes in pages, that one you would await because like that was the revalidate one was actually the request that was invalidating the like revalidating the page. What you do now is like revalidate pod, revalidate tag are more like purging methods. So
Mm-hmm.
you basically
Got you.
purge the cache instead.
Got you.
And then the rendering itself that happens after your function runs. It's like we wait for your function to complete. So that's the one that's awaited, like your function itself. And then at the end of that, we basically like collect, like while you're calling revalidate tag, we basically like keep an array of like these are the pods that you're, or like these are the tags that you want to invalidate. Um, one of the mind blowing like things about this is like revalidate pod is actually just like revalidate tag with a
Mm,
particular like internal key on it. And it can hold like more like it can hold HTML and stuff like that as well. So in the future, we basically expect that like the data cache and full route cache are the same thing. The reason that we're explaining them as two separate things is that they're conceptually like if you're thinking about it, they work in a slightly different way and they run at different times as well. Like you see them in build instead of like well, here's the thing, you can also see the data cache at build time. You can
mm-hmm.
say like I'm going to render like the header at build time. That will actually seed the cache as well, and that will be
Uh-huh.
used during like dynamic request as well. Um, but like conceptually, like the HTML and RC payload, like the entire payload for static pages is like separate thing in the same like underlying caching mechanism.
Interesting. Kind of along those same lines, someone asked on Twitter, and I've also had this question about like an ORM. I wonder if you guys had ever, over the 7 years you've worked on Next, thought about an ORM that would be something that potentially could do some of the stuff automatically, right? If Next had knowledge of the data dependencies, it could build the surrogate keys like you mentioned before. It knows
Yeah.
you're modifying post:1, and so it can automatically purge all the cache entries that rely on that. Have you guys ever talked about that? Or yeah.
And ORM specifically not, but about this case of like if I call my my SDK where like say you're using like I don't want to try anyone under the bus, but like say you're using a CMS provider. The CMS provider has like already has this like SDK for Next.js, for example.
Mm-hmm.
They could actually totally like build in their validated pod or validated tag into their
Mm-hmm.
SDK instead, right?
Mm-hmm.
So
Mm-hmm.
at that point, you basically say like I'm updating my post, or like I'm inserting something into my cart, or like I'm doing a like database update. Okay, now I'm going to call like that one is going to call revalidate pod or revalidate tag, and everything will work automatically. So
Right.
then the code that you as a user are writing is just like await like ORM provider dot insert, and then like
Right.
it will do it automatically.
Right. Very cool. Awesome, man. Anything you want to say before we wrap up?
Um, Good question. No, I would recommend like trying out the like app writer. Let us know what you think. The thing as well, if you've tried app writer before, we've been working on like a lot of performance improvements. So both in the memory usage like side of things as well as development performance, production performance. So if you used like app writer slightly after it came out and like ran into issues or anything like that, would highly recommend like trying it again on the latest version. So like install like npm install next at latest, and you'll basically be able to like in some cases like we saw like a over 10x performance improvement for development because of like various like OS specific conditions that we ran into, which is like we do a whole podcast on that by itself. Um, but yeah, like now is a good time to try it out again. And we're still working on like ironing out like smaller bugs and things that people are running into. This like caching thing I was talking about, the 30 seconds, that being configurable or not, is like one of them. It's definitely like still try like working towards like new features again, but like right now we're really like heads down, making sure that everything is like as performant as possible, and that like the things that people are reporting are actually solved as well. So you might not see like massive new features, but instead what you'll see is here's a lot of performance improvements. Here's like bug fixes that you asked for, and education materials as well, right? Like so we did a new caching documentation that this like everything we talked about today, but
Mm-hmm.
in a form that has like the visuals as well for
Mm-hmm.
it. And then um, we're also still working on like the Learn course, for example. It's like Next.js Learn is going to have an app writer version of that very soon, which will basically like help you walk through all these concepts. Like how do I fetch data from database or external source? How do I update? What do I do with like server actions, for example? Things like that. We're still working on server actions as well. Like I mentioned, like they are moving towards stability. We're working on TurboPack, so it's getting very close actually. Like really excited to see where that goes. Could spend a whole episode on that as well, but like the quick overview here is like why don't we use like another like bundler or like bundling thing, or like why don't you keep using Webpack as well? Is like a question that comes up sometimes. It's really about like with server components, what we're expecting is that people are going to build even larger JavaScript apps. with even more code. Like what we're seeing now is that there's like icon libraries that ship like 11,000 modules in a single module. So like
Nice.
those all have to be bundled and packaged in a certain way in tree shaken. Um, we're trying to do like these optimizations there where like you basically get this like it's not about like beating the existing like standard basically. It's more about like how do we make sure that this thing because the thing that we didn't really talk about is like this is the architecture that we want to build for the next like 5 to 10 years for Next.js. And like in order to get there, we basically need like the performance for development to be in a certain shape as well. Applications keep getting bigger. Like our own application, like for sell.com is getting like larger by the day as well because like we have like hundreds of engineers now, and in order to get there, we basically need the framework to level up that like bundling as well. And server components doesn't have like a native bundler right now, right? Like we build like something for like using Webpack, but it actually means like you have three Webpack instances that talk to each other to basically like figure out what is the like combination of bundles basically. So what if we get like a native like single graph, so single JavaScript graph that can output both server components, client components, and things like that. There's like a whole like lot more detail to this, but like TurboPack is definitely going to be like this like bundler that has the built-in React Server components, and that's like where we're at today already. So I'm excited for that. I'm excited for the education materials because like that will really help people understand like how do you build this well, and like there's people that are much better at explaining all this stuff than me and creating this visuals. Um, so yeah, that's mostly it. I've been enjoying listening to you talking about all of this in the podcast as well. I think it's like yeah, there's like a lot of like this is a big shift, right? So like totally understand that like not everyone's going to like it. I personally like this is something that I've been working on for quite a long time. So like in the end, like I understand the concepts myself already, which makes it like harder for to see like, oh, this is the thing that like is harder to understand for others. But the DevX team at Vercel has been super helpful there as well, like talking to like both customers and people in like on Twitter and in GitHub and all that. So it's been nice to see that like this collaboration with them is going really well as well.
Nice. I'm so glad you guys are writing three Webpack servers and not me to talk to each other. Um, dude, I've really enjoyed watching you guys and the whole team build this out. I kind of know what you mean. Like it's new territory, um, and it's but it's exciting. I think people can sometimes get carried away, especially people who, are very online on Twitter as using that as like their rubric for when they should be using something or learning something. Me and Ryan and all of our education stuff that we've done, really, it's pretty simple advice. The way we think about it is, the website and the docs are kind of the guiding star, like the North Star, the guiding light. And, you know, I've seen Dan talk about this a lot online, where there's a tension between exposing your thought process, the work in progress, what you're doing, but versus people getting excited and jumping on. But I know we've seen a lot of people really excited about the work and found it really been really successful with it. And I know you guys have to deal with a lot of criticism on Twitter. So I just want to say, from my perspective, I really appreciate all that time that you put into communicating, because you guys would be totally justified in working behind closed doors as you're figuring this stuff out, but you've chosen to be more public for our benefit. So I appreciate that. I know it can come with some frustration sometimes, or people being critical, but I know I've learned so much from you and the whole team just being open and public with that. So appreciate that.
Thanks. Yeah, there's definitely obviously been like a lot of conversation about like RC and all that. I did want to mention one more thing, which I forgot to mention earlier, which is that the React team has been pretty open about like documenting more of RC and they're actively working on that. So like the React.use and things like that are already being documented. Um, and like there's a lot more coming there basically. So I wanted to give them like a shout out of like it's coming. It takes a lot of effort to write all these docs, and
Hmm.
obviously like the like server components have been in the React Canary channel, which is like it's not stable basically. So
Hmm.
it's like this new channel where they can collaborate with framework authors to
Hmm.
basically get to this point where like we're going to put it in React stable for everyone, while we iron out all the like individual pieces that might actually like break or mostly like break as in like break people that are already using the stable React, right? So like if you're using
Hmm.
the React Canary, like Next.js can like smooth over a lot of the changes that happen there. And obviously, like we're working with the React team, like some of the members of the React team are working at Vercel
Hmm.
as part of their own team as well. So we're collaborating with them with Next.js. So it's been and that collaboration has been really good as well. So like we're in a spot now where like things that previously like Next.js had to do, where like we just like loading code, making sure that the like meta tags are like correctly injected into the head. Like we created this like next head, which you've probably used. Next head is like a custom renderer of JSX in a way, and that causes issues as well. So now we have like built-in support for like meta tags being rendered as part of the React tree as well. So there's
Nice.
like things that the folks working on React at Vercel have been able to contribute into React itself that actually help everyone, right? Like not just Next.js is going to help like other frameworks as well.
Nice.
Um, where like it's preloading, it's like injecting things into the head, async transitions, which is like a big thing in server actions. This basically means like what if you can run a function that is like start transition async instead of like start transition a function that can't do any async
Hmm.
work, which then means that the rate that you do is part of the same transition, so you can use the data that comes back from this like API call that you're doing to then do a set state, which
Hmm.
means that if you do this fetch and then do the like set the state there, React will automatically keep track of like all the updates that come after it as well. So if you like, for example, do a good example is like an input field where the like the results are fetched, basically, it will automatically do the like apply the right last state after you stop typing.
Very cool.
And stuff like that is really interesting. Like obviously, like I said, it's many things that you could do a full podcast episode on,
Hmm.
and like all these new like all the new features that have landed. But it's interesting to see that like all of this is like kind of fitting together into this like Next.js package of like here's the framework to do like many of these like smaller UX things that you could previously like either like you could do it, but it was massive effort to do it,
Or is outside
or
of
you
React.
couldn't do it at all, right?
Right. Very, very cool. It's cool to see that stuff coming to React proper, first class. Like I'm excited about when you talk about things like transitions and async functions, I'm thinking about like animations, and I know that's always been in the back of the React team's mind, but it's cool to see you guys working together. And yeah, hopefully people can listen to this if they're curious, but again, like you said, it's work in public, it's on progress collaboration between Next team and React team. Don't feel like you have to run away from this and go update your applications. That's how I treat this stuff. And I don't ever feel, again, that anxiety that you see sometimes with the people who are public about being critical or whatever. This is kind of like I think of this as research. It's like ongoing research. We're getting to look into the minds of the research scientists and learning along the way. And hopefully, for folks, that mental model discussion is that always helps me see what is the end game here, right? You're not having to think about this stuff, but the caching stuff or the different components being rendered in parallel. That's how it happens. But the mental model is this co-location, this componentization, interweaving client and server features. That's how you want to be thinking about the paradigm. And so for that, I think that was really great, super helpful. And man, I really appreciate your time. This was awesome.
Thanks for having me.
Cool. All right, let's wrap it up. And thanks for listening. And we'll talk to you next week. All right, thanks again, Tim. Bye.